Hello, guys. Welcome to Ramtar Solutions. Welcome to the Organic Molecules series. Today, the lesson focuses on alkynes, and this is all you need to know about alkynes. As you can see here, this is how alkynes looks like. Remember, they are unsaturated hydrocarbons with triple carbon-carbon bonds. Okay, so without any waste of time, let's get into it. Right. So, how is this video structured? First thing first, we're going to give you a brief of what are alkynes, then proceed to the naming of alkynes, showing you how alkynes are named, the system that is recommended by the IUPAC, and then conclude this video with examples that includes the drawing and naming structures of alkynes. Okay, that includes the drawing and naming of alkynes. All right, so in the opening slide we said they are unsaturated hydrocarbons with a triple carbon-carbon bond. Of course, we should say at least one triple carbon-carbon bond. Okay, and remember, guys, by saying at least one triple carbon-carbon bond, we are saying it can have more than one triple bond. Okay, it can have more than one triple bond. All right, and then another thing you should know about alkynes is that they are more reactive than alkanes, and even your alkenes, right? They are more reactive. They are the more reactive hydrocarbons. Okay. And when we name alkynes, I'll give you an example. The simplest alkyne, or one of the alkynes that we know, acetylene, which you also call ethyne. All right. So this therefore implies that the suffix of alkynes are YNE, right, which is yne, YNE, okay, YNE, which is yne, right? Now, I just said to you the simplest alkyne is what we call ethyne, commonly known as acetylene, isn't it? Commonly known as acetylene, right? Then the general formula, you guys recall alkanes, you guys recall alkanes, their general formula were CnH2n plus 2, and then alkenes had two less hydrogens than alkanes. All right. Then this was for a single bond. Then alkenes for double bond, they had two less hydrogens. Now alkynes will have further two less hydrogens, meaning from alkanes, alkynes will have four less hydrogens. Hence, it is not surprising that it is 2n minus 2. Do you remember? They have two less hydrogens than alkenes, meaning four less hydrogens than alkanes. Okay. All right. So, by virtue of them having less hydrogens, it therefore means they undergo addition reaction. Okay, by virtue of them having less hydrogens, it means they undergo addition reaction. Okay, with regard to their solubility, we are not going to talk much about their solubilities, their boiling points, and so on, because there is a lesson dedicated to them later on. However, just to give you a brief, most of these alkynes are insoluble in water. Okay, they are insoluble in water, but just so you may know, they dissolve in organic compounds. And that triple bond makes it difficult to break. Therefore, they have boiling points. Okay, they have boiling points that are greater than alkenes and alkanes. Okay, by virtue of that triple bond, they have boiling points that are higher than all the hydrocarbons that we dealt with. Okay, so boiling points of alkanes and alkenes are lower than alkynes. Remember, with regard to boiling points, it is this: alkenes, the boiling points of alkenes is lower than the boiling point of alkanes, and the boiling point of alkanes is lower than the boiling point of alkynes. Okay, so for molecules of the same number of carbons, alkenes will have lower boiling points, alkanes will have one higher than alkenes, and then alkynes will have boiling points higher than hydrocarbons of the same size, isn't it? Oh, yeah. Now, except ethyne, or what we call acetylene, all are odorless. Okay, all are odorless. Remember this one, they like saying it smells garlic like, right? They say it smells garlic like. Okay, it smells garlic like. I'm not used to these things, guys. Okay, I'm not used to these things. So it smells garlic like. Okay, so except ethyne or acetylene, all alkynes are unscented. Unscented, or you can say they are odorless. And remember, they are also colorless, okay? They are also colorless. All right. Now, let's get to the uses of alkynes. So, the uses of alkynes are oxyacetylene torches that we find in welding. That flame is alkyne in action. Ethyne. Ethyne, guys, can be used to create your alcohol. Okay, it can be used to create your alcohol. Further, artificial ripening of fruits, we can use alkynes. I have this thing where I like ripening my avocados using your A4 papers. I don't know. I found that A4 papers are somehow creating a speedy ripening process. I didn't know, guys. It's only until recently. I used to use newspapers, but I saw that when I use um A4 papers, the ripening is fast, and I was impressed with the results. But I don't know. I didn't investigate. It was just me looking using that because I remember um I ripened my mangoes using was it a newspaper? Yeah, it was a sort of a catalog, and it was taking long. It was taking long, but of course there was mangoes. But now, because I used um A4 papers for ripening avocados, I don't know if really there's a difference between a catalog and a clean A4 paper. I don't know, but this is what I found. Okay, it wasn't an investigation, but I'm yet to pursue with um avocados in the next. Mangoes with the next mango season. So I'm yet to see that. All right. Okay, so alkynes are also used in pharmaceuticals. So we're not going to dwell much on this. Lastly, they are your precursors of polymers. Okay, they are your precursors of polymers. Okay, meaning they are part of the monomers in the production of polymers. Okay, all right. Now, let's then head to how do we name alkynes? Of course, we've been saying all along that the nomenclature used is in line with the IUPAC system. So remember, it says one. What does it say? One, it says recognize your functional group. Your functional group in alkynes is a triple bond. Okay. You must also indicate the location of that functional group. Okay. You will see that later when we draw and name structures of alkynes. Secondly, find the longest continuous carbon chain. Here I like saying the maximum number of carbons, guys. The maximum number of carbons. Okay. Find the maximum number of carbons in your molecule. Okay. And then when you then proceed to numbering, when you number the longest chain, begin with the end nearest the triple bond. Okay. Begin with the end nearest the triple bond. Then name each substituent. Okay, name each substituent, including the triple bond. Your bond will be in, diene, and so on. Okay, so name each substituent. Remember, your substituents are your halogens and your alkyne groups, right? Then begin the name with the number or numbers of the carbon to which each substituent is bonded. Okay, to which each substituent is bonded. Remember, I am emphasizing that you must also indicate the direction or the number of carbon where you find your double bond. This is alkynes, where you find your triple bond. Okay, you must also state that. But let's not confuse this. Begin the name with the numbers of the numbers of the carbons to which each substituent is bonded. You will see that when we name them. Okay. Then when you have two or more substituents, you need to list them in alphabetical order. But if you have substituents of the same kind, use the prefixes di, tri, tetra, penta. I believe by now you are used to this. And guys, this also applies to the triple bond. If you have more than one triple bond, also use the di, tri, tetra, penta, and so on. Okay, also use them. All right. Tada. Then now we can go to our examples. I know a lot of you have been waiting for that. Let's go to our examples. But before we go there, let's then remind you of the naming that is used in alkynes. You remember that when you have two carbons, longest chain of two carbons, you say F3 prop 4 but 5 pent 6 hex 7 hept 8 oct. All right. So remember I said the suffix of alkynes is Y and E. So an alkyne with two carbons is called ethyne. Remember acetylene is called ethyne. And propyne. And then with the hydrocarbons or alkynes with four carbons and more, I put an asterisk here to say, this asterisk is to say the name can be different. You can have more than one name for the same molecule. You can have two butyl, you can have two pentyne, three pentyne, you can have two hexyne, three hexyne, four hexyne, and so on. Okay, but you are going to see that later. Okay, you are going to see that later. But these are the ones which are most common. Okay, these are the ones which are most common. And I need you guys to know this. The first three alkynes are gases at room temperature, and the rest of them are liquids at room temperature. Okay, the first three are gases at room temperature, and the rest are liquids at room temperature. Okay, all right. Now, before we go to our examples, let's then look at substituents. We've been emphasizing this in almost all videos, that we have these alkyl substituents: methyl, ethyl, propyl, butyl, isopropyl. Now, the difference between propyl and isopropyl is this. With propyl, it looks like this. Let me use a different color. With propyl, this is propyl, right? It is like your propane, but with one less hydrogen. Okay. Remember, normally here there was going to be an H, but no, because it's an alkyl group, your longest chain will be attached to this component here, making it propyl. Okay. Now we have isopropyl. Isopropyl, the longest chain is no longer bonded to the last carbon, but to the central carbon. So it'll be like this. This is isopropyl. Okay. This is isopropyl. Okay, this is isopropyl. The longest chain will be bonded to this central carbon. Okay, that's the difference between them. Remember, this is propyl and this is isopropyl. Okay, this is isopropyl. Okay, happy? Hey, tada. All right, so this is what you need. And remember, with substituents, you also have halogens. I'm not going to focus more on them, but yeah, they are there. Where with halogens, the names, the INE of your halogens, the INE of your halogens just changes to O. So in other words, the INE becomes O. Fluorine, fluoro, chlorine, chloro, bromine, bromo, iodine, iodo. Okay, that's all you need to know. All right. Now, let's get to our examples. Let's get to our examples. Now, let us draw what we call ethyne. Okay, let us draw what we call ethyne. I'm going to try, no, in fact, let me try one at the page. So let us draw what we call ethyne. Okay, let us draw what we call ethyne. Sorry, ethyne, not ethyne, ethyne. Let's try ethyne acetylene, right? Let's try ethyne. Ethyne, F means you have two carbons, but the functional group is triple carbon-carbon bond, isn't it? Triple carbon-carbon bond. Therefore, we don't have any substituent. So this is your ethyne. Okay, this is your ethyne. Happy? Perfect. Now, let's try propyne. Let's try propyne. Prop means you have three carbons. Prop means you have three carbons, but propyne, functional group IYNE, means you have at least one triple carbon-carbon bond. So it'll be, whether you draw it here or you draw it here, it doesn't matter. So let's see. Carbon has four bonds, guys. Okay, carbon has four bonds. So this we need to draw an H here. This, it doesn't need a hydrogen, and this will need three hydrogens. Okay, this is propyne. Propyne, you cannot say it can be one propyne. Even if the triple bond was here, it was still going to be one. Okay, now let's look at the condensed structural formula. It is CHCCH3. Do you see that? Now let's go back to the one of ethyne. It is CHCH. Happy? Perfect. Now, let's then play a bit. Now we have, let's see, I'm going to draw a condensed structural formula. CH3, CH, and then CH3, and then CH2, CH3. You see now, I can tell you that with the CC, it means this is a triple bond here. I can already give you the name that when we start numbering, remember, you start numbering with the end nearest the triple bond. So it'll be 1, 2, 3, 4, I think 5, and 6. I do see a substituent here. So this then becomes, with what I'm seeing, this then becomes, I see the longest chain has 6 carbons, which we will say it's hex, and then it's a triple bond. So it'll be hexyne, right? So where is our substituent? I see it's on carbon number, not number 4, but number 5. Therefore, it'll be, where is it? It'll be 5 methyl, right? It'll be 5 methyl hex, where the double bond is on carbon number 2, hex 2I. If you like, you can say this is 5 methyl, oh, 2, not 6, man. 2 hexyne. Okay, you can also use this name. Okay, you can also use this name. Happy? Now, let me draw the structure. The first carbon, the carbon on the left, so I'm going to draw it from the left to the right. It has 3 hydrogens. It is bonded to a carbon that has one hydrogen and an alkyl substituent. Okay. It is bonded to another carbon that has a hydrogen, two hydrogens rather. It is bonded to a carbon that doesn't have hydrogen and then another carbon. So it seems like it would be three. Do you see this? And then this is bonded to another carbon that has three hydrogens. Do you see this? That is three hydrogens. And of course, let's now show the numbering. 1, 2, 3, 4, 5, 6 or 6. It doesn't matter. So I'm going to go this 6. Okay. Do you see this? Because I cannot, if I go 1, 2, 3, 4, 5, 6, this end is not nearest the double bond, but it is this end from the right that is nearest the triple bond. Sorry, triple, not double. All right. It is the end from the right that is nearest the triple bond and not the end on the left. The end on the left, look at where the triple bond is. On carbon number 1, 2, 3, 4. On carbon number 4. Right? And that is not how we name this. We said you number with the beginning with the end nearest the triple bond. Right? Oh yeah. Okay, now let's try the semi-structural formula. CH triple bond CH2 CH2 single bond C triple bond C single bond CH3. Remember, you start numbering with the end nearest the triple bond. 1, 2, 3, 4, 5, 6, 7. Interesting. But 2, okay? Or 1, 2. Then it means we must start numbering from the left. So we will go 1, 2, 3, 4, 5, 6, 7. This is perfect. All right? This is perfect. So what is this? The longest chain has 7 carbons, which we call September hept, and then it is a triple bond. Where are they? They are on carbon 1. I see another one at carbon 5. Then diheptine. Okay, diheptine. Or you can say this is hept 1,5 diene. Okay, diene. Okay, diene. Okay. Right? You can say this. If you're wondering how did we get this, I don't think we have to draw a structure for this, but let's just draw it. First carbon, drawing from left to right. First carbon has 1 hydrogen, okay, and 3 and triple bond rather. It doesn't have a hydrogen, single bond is fine. The third has 2 hydrogens. The fourth has 2 hydrogens. The fifth has no hydrogen, it has a triple bond. The sixth has a single bond, no hydrogens. The seventh has 3 hydrogens. And this is the structure of your 1.5 diheptine or hept 1.5 diene. Okay, this is it, guys. Oh yeah. Now let's try another one. We're gonna try 6 methyl no, let me not make it pent. But pent won't be bad, isn't it? Nah, no, pent is bad. Let me make it hept 3 iron. Okay, let me change the color. So I do see that when I do this, it's important that I should have different colors. Now, how do we name this? The longest chain has 7 hept Hept means 7. So let's see. 1, 2, 3, 4, 5, 6, 7. Where is the triple bond? The functional group ine, so it means it is a triple bond. Where is it? In the third carbon. In the third carbon. 1, 2, 3. You see that? And then do we have any other substituent? Yes, it is in carbon number 6. So let's begin this. So here you don't need to put an H because we have 4 bonds around this carbon, even here. But here you have to put 2 more, even here 2 more, and here 3 more. All right. So uh-huh. Mm-hmm. Mm-hmm. So let's number these carbons. So it is 1, 2, 3, 4, 5, 6, 7, isn't it? Now, what did we say? We said we have a methyl at carbon 6. We have a methyl at carbon 6. Right? We have a methyl at carbon 6. And this is how you draw the structure of 6-methyl hept 3-ide. Okay? Happy? Perfect. As you can see, the alkyl or methyl is on carbon 6 and the triple bond is on carbon 3. It's between carbon 3 and 4, but this is to say it is on carbon 3. All right. Perfect. Now, let's try one last example. We're going to try, I'm not sure if it's going to work, but let's say we're going to try this guy here. CH3, CH2, CC. Uh, Let me open a bracket here. CC open bracket, CH3 close twice, and then CH3. Now, what are we seeing here? The longest chain will be 1, 2, 3, 4, 5, 6. Can it also be 7? I think 6. So it'll be 6. With 6, what do we call it? We call it hex. Right? Now let's start numbering. It'll be, we will confirm 1, 2, 3, 4, 5, 6. Ooh, I do see that on the 5th carbon, or let's see, 1, 2, 3. Okay, you know what? We're going to try it from this end. Okay, so it's going to be 1, 2, 3. So what are we going to do? We're going to say this looks like we have 5. Okay, we have 5, 5 dimethyl, 5, dimethyl. Okay, dimethyl hex 3-ine. Now let's draw it. Let's draw it. When we draw it, we will say first carbon, we have 3 hydrogens. Second carbon, you have 2 hydrogens. Third carbon, you don't have hydrogens. You are bonded to another hydrogen, therefore you must be a triple bond. So fourth, you don't have a hydrogen. Fifth, you don't have hydrogen, you have alkyl substituents. Sixth, you don't have, you have 3 hydrogens. Right? Let's see now. Indeed, it is. Moja mbili tatu nne tano sita. Right? Oh yeah. Yeah. So this is the structure of this molecule. Do you see now? Check. We moved from each condensed structural formula to each structural formula. We were able to name it using just the condensed structural formula. Okay. And this is how you do it, guys. So I hope you guys now understand that it's important you name like this. I hope you saw the tricks. So, with that being said, I can say to you, we have come to the end of our lesson. And remember, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. And because you are watching on YouTube, you will get links to all these social media platforms. Okay, you'll get links to all these social media platforms. And guess what? The next lesson is haloalkanes. The next lesson is haloalkanes. Okay, guys, the next lesson is haloalkanes. Therefore, let me tell you, therefore, it's a wrap for us. And bye bye.